Okay, let's say we want to perform a one-sample t-test. These notes are about how can you find p-values a fast way and a thorough way, what's happening under the hood. So let's get a context. 5 years ago, the average weight of a species of turtle on an island was 310 pounds. We want to see if that's changed, so we collect a random sample of 40 turtles, find their mean weight is 300 pounds, so a little bit less, and the standard deviation of the weights of those 40 turtles was 18.5 pounds. What's an appropriate hypothesis test that would tell us whether we have statistically significant evidence that the turtle weights have changed? Okay, so the test, the appropriate hypothesis test to use here is called the one-sample t-test. Why is that? So you might remember from before, if you have an experiment that has to do with proportions, we were using a z-test because the sampling distribution is a normal distribution, which we're calling a z-distribution. So over here, the one-sample t-test is if you can't use a normal distribution. Okay, so why wouldn't you be able to use a normal distribution? The main reason is if your experiment is about averages, if it's about means, and you don't know the population standard deviation. So it's not just about being means that causes the need for the t-test. It's specifically if we have to approximate the population standard deviation because we don't know what it is. And usually that's the case. So usually for an experiment with means, you would use the t-test. All right, so let's get some hypotheses. The null hypothesis is that the turtle population average weight is 310. The alternative, we don't think they got heavier or lighter. We don't really know. So there is no particular direction change implied. It just says we want to see, is there evidence that the weights have changed? So our alternative is just that the average weight is different. We don't think it's necessarily larger or smaller. All right, so in our particular experiment, the sample average we found is smaller. And so we want to know what's the probability that we would have had a sample average that's that much smaller, even if the null hypothesis is true. What's the chance it would have happened randomly? So let's go and perform a t-test. Here's a calculator. We'll hit the stat key and go over to tests, and then go down one to t-test. And we're going to perform a t-test based on statistics rather than individual measurements in our data. So what I mean by statistics is we know what our x-bar is. X-bar is just the sample mean, and the sample mean is 300 pounds. So let's type in the stuff. So here we had 300 pounds as our sample mean. This is our null hypothesis mean. And our null hypothesis was we think, or we're assuming, that nothing's changed. We're assuming 310 is the average turtle weight. This is the standard deviation of our actual sample. So this is 18.5. N is the sample size, so we'd sampled 40 turtles. And then this is our alternative hypothesis, and our alternative hypothesis is just not equal. So let's find the p-value. All right, I've updated all my calculator settings. I'm going to hit calculate. And it's given me a t-value, which will come back later. So actually, let's write it down. So the t-value is negative 3.419. But the thing we really care about is this p-value. So that's the probability. So our p-value is 0.0015. So that's a very small p-value. It's less. We didn't state an alpha level here. But this is less than 1% chance. So very unlikely to have happened by chance. So I think we do have statistically significant evidence that something is different. Come back in the next video to understand what is this t-score about and what's actually happening under the hood to get this probability. Like, where does it come from?